Hello everyone. Today our topic is number system. So in mathematics there are basic numbers. Let me draw the number line. So on positive infinity, -1, -2, -3 up till minus infinity. So what are the natural numbers? First are the natural numbers. Notation is capital N. So all the counting numbers 1, 2, 3 till infinity, positive infinity are the natural numbers. Next are the whole numbers. Notation is capital W. So it includes 0 as well in the natural numbers. So 0, 1, 2, 3, so on are the whole numbers. So these are the natural numbers. Including 0, we will get whole numbers. Number third are the integers. Notation is capital Z or I. So these are basically the whole numbers with negative counting numbers up till minus infinity. So all these numbers 0, 1, 2, 3 so on till positive infinity and the negative counting numbers as well gives us the integers. Next are the rational numbers. Rational numbers. Notation is capital Q. So the number of the form P by Q, where P and Q both are belonging to integers, the greatest common divisor of P and Q must be 1 and Q should not be equals to 0. This is the definition for rational numbers. The numbers must be of the form this. Let's take an example. Say minus 41. This minus 41 can be written as minus 41 upon 1. Nothing will change. This is of the form P by Q. So here P is what? Minus 41 belonging to integers. Q is 1 which is not equals to 0, satisfying this condition and belonging to Z. So this condition, both these conditions are satisfied. Let's check the GCD or common factor between these two numbers. Clearly this is 1. So these two numbers are what? Co-prime numbers. They have nothing in common except 1. So minus 41, we have written this in the form of this. So clearly this number satisfying all three conditions. So this is a rational number. From here we can see that minus 41 is an integer as well. So it is clear that every integer can be written in the form of P by Q. So will satisfy all the conditions. So every integer is a rational number. So if I draw this diagram, if these are the natural numbers, then these are the whole numbers. Whole numbers are having all the naturals. Next are the integers. Integers are having all the whole numbers. Next are the rational numbers. Rational numbers are having all the integers. So every integer is a rational number, but every rational may or may not be an integer. Every integer is a rational, but converse may or may not true that every rational may or may not be an integer. So these were the numbers. Next are the irrational numbers. So what are irrational numbers? Notation is capital P. So the numbers which are not rationals are the irrational numbers. So when we combine these numbers, rational and irrational gives us the real numbers or real line. This is real line, real line in mathematics. So every real number can show on this number line, and real numbers are what? Notation is R. So real numbers are what? Collection of rationals and irrationals. So real numbers are what? Collections of rationals and irrationals. So every real number can be shown on this number line. Let's do a question. How we can find rationals between any two numbers? So the question is, find C6 rational numbers between 3 and 4. How will we do this question? We will just add up the numbers we are given. Sum is 7. So 3 will be equals to, take this sum in the denominator and multiply these two. Put that value in the numerator. So 7 3s are 21. We will write here. Next number is 4. We will write this sum in the denominator. We will multiply these two. 7 4s are 28. Now we have 3 as 21 by 7, 4 as 28 by 7. So we can get the rational numbers in between these two numbers as, we will write here, the next number will be 22 by 7, next 23 by 7, 24 by 7, 25 by 7, 26 by 7. Next is 27 by 7 also. So these are 6 rational numbers. We will check the condition of rationals. So all the numbers individually are integers. Common factor is 1 here, and q is not equals to 0. All are of the form p by q. So this is the answer. These 6 numbers, these are the answers for this given question. Just add up the numbers, make that addition denominator of the number, and follow the procedure, get the result. Next is, so examples of irrational numbers are irrational numbers, capital P. Examples are root numbers, root 2, root 3, root 15, root 17, pi as well, etc. These are all examples of irrational numbers. So next is the decimal expression of reals. Reals means rationals and irrationals. We will discuss how to express these as decimal forms. So if we have a rational number in decimal, it may be of two types. One is terminating. Other is if it is non-terminating, as well as reoccurring. What does it mean? So rational numbers are what? In under decimal expressions, rational numbers may be terminating, otherwise non-terminating, as well as reoccurring. What we mean by terminating? Let's check here. Say terminating we are discussing here. Say I have this number 43 by 1000. So we know how to express this in decimals. We will just count the number of zeros 3 zeros are there, and counting from the right hand side of the number 1, 2, we'll put a 0 here. So 1, 2, 3. Put the decimal here. This is the decimal expression for this number. So this expression, this decimal expression is what? Terminating. It is ending somewhere. It is ending at 3. Ending at 3. So when a number ends, it is called terminating. So this number is clearly what? A rational number. Second case is non-terminating and reoccurring. Non-terminating and reoccurring. Let's take example 1 by 11. How will we do this? We will just take 1 inside dividend, 11 is the divisor. So 1 is of no use, 1 is less than 11. So we will put decimal here and write 0 here. Again 10 is less than 11, this is of no use. We will put a 0 here to borrow one more 0. Now this is 100 greater than 11. 11 nines are 99. Remainder is what? 1 again. So from this decimal we will write a 0. This is again of no use because 10 is less than 11. To borrow more 0, we will write a 0 here and here also. Again at 9, this is 99. Again the process is repeating itself. So this will go on. This will go on. So here the number is what? This number 1 by 11 is equals to 0.09090909 and so on. It will goes on. It is never ending. This number is never ending. So what we will do? We will write this as 0.09. Clearly two numbers are repeating itself. So we will put a bar on these two numbers. This means that this number is repeating itself and it is never ending. Bar means this. So this number is what? Non-terminating. It's not ending. Reoccurring means that some digits are repeating itself again endlessly. So reoccurring means repeating and non-terminating means never ending. So this number is satisfying both the conditions. So 1 by 11 that is equals to 0.09 bar belongs to rationals. So this was the decimal expression of rational number. So whenever a number is terminating or the number is non-terminating and reoccurring, that number will be a rational number. Other way, when we have such numbers, this number and this number, so these are ultimately the rational numbers. If rationals are given, expression will be like this. If expression is like this, then these numbers are clearly rational numbers. So this was the decimal expression for the rational numbers, and the decimal expression for the irrational numbers is says irrational numbers says these numbers are non-terminating and non-reoccurring. Non-terminating, non-reoccurring. For example, root 2. The value of root 2 is 1.414213562, so on. It will goes on. So no digit is repeating, no set of digit is repeating here. So this is non-reoccurring and non-terminating. It's not ending somewhere. Value of pi is 3.141592 and so on. No digit, no set of digit, not a single digit are repeating themselves. So these numbers are what? Such numbers which are non-terminating and non-reoccurring are the irrational numbers. So this was all about today's video. Hope you understand well. Hit like if you are liking my video and subscribe to my channel. Thank you.